Welcome once again to my YouTube channel. So today we are taking a topic in physics on a topic, Newton's laws of linear motion. We have three laws propounded by Newton. The first law is known as law of inertia. The second law is known as law of momentum. And the third law is known as law of reaction. So we start with the very first law. The Newton's first law of motion states that every body continues in its rest position or of its uniform motion unless there is an applied force. I repeat, the Newton's first law of motion states that everybody continues in its state of rest or of uniform motion unless there is an external force applied. What the law says that there is nothing that will make a body to leave its position except there is what? Applied force. When you have book placed on a table, the book remains there. The only thing that will cause the book to leave the very position is when force is being applied. If a body is moving along a straight path in a uniform motion, the body continues in such direction unless there is an applied force that will make it to change that very direction. That's all about Newton's first law. And the reason why it's referred as law of inertia, like we know that inertia is the reluctance to change. Take for example, if you're in a moving vehicle and suddenly the vehicle stops, you'll be forced to jack forward. If the body tends to move again, you will then be jacked backward. That reluctance in you is what we termed inertia. So a body will remain at a position unless there is what? A force that will either push it forwardly or backwardly. So that's all about Newton's first law of motion. Now let's get to Newton's second law of motion. The law we termed law of momentum. Of course, we know that momentum is the product of mass and velocity. Now, once there is a change in momentum, then we consider the final momentum minus initial momentum, which will now give you change in momentum. Now, what the law says on momentum, that's the Newton's second law. The Newton's second law states that the rate of change of momentum is directly proportional to applied force, and it takes place in the direction of the force. Let's go to the board and take it mathematically. So the second law states that the rate of change of momentum, is directly proportional to applied force. Look at this. Where this is the change in momentum, this is what? Applied force. So the rate implies that the change in momentum with respect to what? Time. Okay? So at this very point now, this means change in momentum, which is the final momentum minus initial momentum. Momentum is the product of mass and the velocity. So where v is the final velocity, u is the initial velocity. The mass of the body remains the same all through the journey. So in that very case, we have mv as the final momentum, while mu is the what? Initial momentum. Then again, we have the change in time. When the time is reached from 0 to that very time t, the change in time becomes t minus 0, which will now give what? T. So with this, the force, applied force, is directly proportional to change in momentum. So this is the change in momentum, mv minus mu all over change in time. Change in time now is t. So at this very point, we have the mass to be common. So if you factor the mass, we have F is directly proportional final velocity minus initial velocity all over time. Now with this, we remember that acceleration is v minus u all over time. That's the acceleration. So we can substitute v minus u over t with acceleration. Hence, we now have that force is directly proportional to mass times what? Acceleration. Then, if you introduce a quality constant, we are going to have force equal to constant ma. Now, when k is equal to 1, then we have the force equal to, k is 1 now, m times a. And this is the simplified form of second law of Newton based on linear motion. We have the product of mass and acceleration being equal to the force. Now let's get to the third law. The third law. The third law states that in every action, there must be a reaction. And the action and reaction are equal and the opposite. I repeat, the third law of linear motion states that in every action, there must be a reaction. And the action and reaction are equal and opposite.